Okay, so if I just write this reaction in simple terms, not in the textbook, I'm just giving it, okay? So we'll take it like this. I add ethanol and then we add potassium dichromate, right? So potassium dichromate means we are adding Cr2O72 minus ions, okay? Plus H plus ions. That is from dilute sulfuric acid. Clear?
Yeah.
Now there is reason to add dilute sulfuric acid so that it will acidify the solution and the redox reaction will take place, or else the reaction won't be acidic enough. And now I will have ethanoic acid here, or a carboxylic acid. Now because this is ethanol, it goes as ethanoic acid. If it's propanol, propanoic acid. Plus I will have Cr3 plus in my system or in my test tube. Why? This has reduced. Cr2 plus Cr2O72 minus will become Cr3 plus, and then
Does the color change only happens when you add potassium dichromate and sulfuric acid?
yes, because the
Okay.
color belongs to the dichromate ion. Now why are we adding dichromate here? To observe the color
It's
change. So okay, it's a
does
oxidized,
it replace also like displacement?
not displacement. This is redox reaction. Displacement reaction is different. Now when AB plus C becomes AC and D, that is displacement reaction. Now you will not come and ask if
Oh,
this is combustion reaction. No, you know only when we have oxygen, combustion will happen. So this is
yeah.
just a totally different type of reaction. This is redox.
Oh, redox.
Yeah.
Okay.
Redox means when both oxidation and reduction take place in one reaction. Okay. So, okay, if I
Yeah.
just write it
I'll
like,
write this down.
yeah, ethanol plus Cr2O72 minus ethanoic plus Cr3 plus. So this is reduction and this is oxidation. Okay. So both oxidation and reduction taking place in the same reaction. This is redox reaction. One reduces, the other one oxidizes. Gaining, it is happening because of gaining and losing of electrons. Displacement is one moves and then the other one comes and bonds in that element's place. Okay, that doesn't happen here. So here when this Cr2O72 minus changes to Cr3 plus, the color changes. That is the observation what we see, green, and this is orange. Okay, so when the solution turns green, we can confirm that Cr3 plus ion is formed. Why? Because in the syllabus or in chemistry, we know that Cr3 plus is green. Okay,
Yeah.
clear?
Okay, Miss Andan.
Understood?
Yeah.
Okay, so you can you draw this if you want? You can just draw it orange. and then put an arrow, write it as oxidation. Water bath. We have green because we have Cr2O72 minus here, and this indicates it has Cr3 plus. And who acts as the oxidizing agent here? Potassium dichromate, okay?
Isn't it the redox flow, miss?
Yes,
When
it
you
is a
add both,
redox. Huh?
when you add the potassium dichromate and sulfuric acid, and it turns into no, it's ethanol plus Cr2O72 minus plus O8, I mean H plus, gets turned into ethanoic acid and Cr3 plus. That's a redox, right?
Yes, that's a redox reaction. So I'm saying who acts as the oxidizing agent here? What is oxidizing agent?
The one that undergoes reduction.
Okay, who is the oxidizing agent here then?
It's
Which one has undergone reduction?
the ethanol.
No. Who has undergone uh, reduction?
Reduction is gain of electrons. So
Okay. So no, go to this box here.
Cr2O7.
Cr2O72 minus has undergone reduction, okay? Yeah, gain of electrons. Correct. Ethanol to ethanoic acid is oxidation. Why? It has gained oxygen. Okay, then for sure the other one should be reduction. Or else, in other terms, I said you this has an oxidation state of +6, this has an oxidation of +3. So if the oxidation number reduces, then it is reduction. Okay.
Yeah, that means Cr2O7 minus is the
Okay,
oxidizing
now
agent.
we will take it like this. Yeah, just okay, forget about all the definitions. We'll just yes, that is the oxidizing agent. Okay. Okay, now we'll just forget about all that and say this. For this reaction, oxidation, reduction. Oxidation is gain of oxygen, right? Ethanol to ethanoic acid. You know, when alcohol becomes a carboxylic acid, it gains oxygen. Are you okay with that? Why? The OH
Yeah.
here becomes C double bond O OH. So see gain of oxygen. So that is oxidation. Now see reduction is loss of oxygen. See there was oxygen here. Now do I have oxygen in this side? In chromium? No, chromium has lost oxygen. So that's reduction.
Yeah,
Clear?
okay.
You can just read it like that also. And then if, okay, write this term, put this term mark and write then oxidizing agent. Here is potassium dichromate. Okay. Clear?
Miss, if it's potassium dichromate, where's the K? So
Okay, in this.
potassium. Yeah.
I just left it because we are not writing the whole full reaction. They will not ask you. I
Oh,
just gave you this reaction to just to understand, okay? Because that is a spectate ion node here. Potassium will not undergo any change, right? Here in this
yeah, it
reaction,
wouldn't
it
go
will not.
under any change.
Yeah, so it's a spectator. I have just left it.
Miss,
If
what's the name for Ci3 plus?
chromium ions.
Chromium. Okay.
Okay. Now here,
Yeah.
if they ask you the reaction for this, they will ask you this reaction. Okay, wait before I come to that. Okay, put the next star mark under that and then write. Dilute sulfuric acid is important.
Okay, miss, I'm done.
Okay. Can you send me a note? Okay, now if they ask you the reason why we add dilute sulfuric acid, this is the reason, because for potassium dichromate to act as an oxidizing agent, we have to acidify the solution, okay, or else it's not strong enough. And then this is a, if they ask you what type of reaction this is, then we say it's a redox reaction. Again, for if they ask us the reason, because both oxidation and reduction takes place at the same in the same reaction. So then uh, it's a redox reaction. Okay, so quick, we'll just revise it again. If they ask alcohols can undergo two types of reaction. That is combustion, and then we have oxidation reaction. Oxidation means gain of oxygen here. This can happen with the help of microbes, or in the lab we can do it by using potassium dichromate with dilute sulfuric acid. Okay, with whatever it
Yeah,
is, the oxidation of alcohols will result in carboxylic acid. So if it's ethanol, ethanoic acid, propanol, propanoic acid, it comes like that. The carbon number doesn't decrease, only the oxygen number of oxygen has increased. So the functional group increases. Now, if I want to do this in lab, I take alcohol in a test tube, then I add K2Cr2O7. That's going to be orange in color. And I can also acidify the solution. So I to add in H plus, that is H2SO4. Okay.
yeah,
With time, now I show, with time, the observation I'll see is this will turn green. Now I know I added Cr2O72 minus ions, right? So green means it confirms that now it has chromium ions in it. Okay. So if I write the reaction, it is ethanol plus Cr2O7 2 minus. If I want, I can just write it with K also. I'm not taking it because it's the spectate ion, okay? With acidifying it, so H plus. Now I'll have ethanoic acid plus Cr3 plus, and then I'll also have some of the H plus ions in my, I can have some H plus ions also in the solution, because ethanoic acid, the word itself says it's an acid. So I will have H plus ions in my solution, no? What is an
yeah,
acid? Anything which releases hydrogen ions in the aqueous solution, okay? So Cr2O7 has become Cr3 plus, ethanol has become ethanoic acid. Now OH has become double OH, C double OH. So gain of oxygen, this is oxidation. See, there was oxygen in chromium, now there is no oxygen, so this is reduction. Reduction is gain, loss of oxygen, this is gain of oxygen, okay? Both happening in the same reaction, redox. If they ask us what type of reaction, all that, and then who is the oxidizing agent here? Potassium dichromate. Who is the
yeah.
reducing agent?
The ethanoic acid.
Ethan. Reducing agent.
Ethanol.
ethanol, okay, which undergoes oxidation is only the ethanol reducing agent, right? Clear? These are the questions you can
Yeah.
get. And now this is, I wrote this reaction just for you to understand. Writing this reaction, drawing the structural formula with all these potassium ion and chromate ions is going to be complex. So that's not given in your syllabus. This is the reaction they will ask you. You should memorize this reaction. So see example, we have alcohol without writing all those what I say, potassium dichromate, and then without writing H2SO4, we just add only oxygen. Because oxidation, right? I know oxygen is only getting added, so writing the simplified reaction, okay? And now I can just draw an ethanoic acid and water. Clear?
Yeah,
But you
clear.
should know the balanced equations. It's 2O, okay? Because with one oxygen is from here, and then one oxygen goes here. Balancing equation. Can you take this whole thing down? And now the conditions heat under reflux. I'll explain you what this reflux is. Do you know what is this heating under reflux and then why we have a condenser here?
A reflex condenser. It's so the alcohol is left behind.
Yeah, something like that. Okay, we'll see. Let's take this reaction down.
Is that two oxygen?
Yes, that's two oxygen.
Okay, Miss, I'm done.
Okay. Now heating under reflux means now if I just heat it without closing this or without connecting it to a condenser. Okay, what happens in a condenser?
Condenser, cold water is put in and hot water goes out
Okay. Oh,
so that the gas particles will condense back down uh, into the what's called beaker, like outside into the
yeah, if we
like
connect this to a beaker,
as a
yes.
pure substance. Yeah,
So pure substance that we looked at under the separation technique. Okay, now condenser, what happens inside the condenser is the vapor turns to a gas. Okay, condensation happens. Sorry, vapor turns to a liquid. Condensation happens there.
yeah,
Okay, now if we have alcohol, when we heat alcohol, it is a highly volatile substance, so it can just evaporate. And then even in the last class, you asked me like water. We heated water at 30 degrees, 300 degrees Celsius, right? For the reaction for oxidation of alkenes, no? Not oxidation, alkene to alcohol. Alkene turning into an alcohol, the hydration reaction. The condition is 300 degrees Celsius, right? So you asked then water has a boiling point of 100, so it can vaporize, right? So there is a problem there. Okay, so the same thing can happen here also. If we heat it, alcohol has a boiling point of somewhere around 78 degrees Celsius. It has a low boiling point, and also it is a volatile substance, which means it can evaporate easily. So it can just vaporize and then escape out. Okay, so it will all the alcohol won't be reacting when we keep on heating it. It can just evaporate. So to prevent that, what we do is we connect our apparatus to a condenser. And what happens inside the condenser is the gas, whatever the vapor goes up, it condenses and comes back into the mm, flask here itself. Understood? So it drips back into the flask. So we still have the alcohol solution, and then it is allowed to react with the acidified potassium dichromate and H plus ions here, and then all the products would be formed. Clear? So reflux condenser means again it's the condenser. They have named it like this. Okay. So reflux condenser means we heat it under reflux. We heat it. We keep on heating it, and then when it vaporizes again, it can just form the liquid and come back. Okay. So all the alcohol will not just escape out. Clear? That
yeah,
is the setup here. Ethanol is refluxed. So ethanol is refluxed or heating under reflux means whatever the vapor forms, again we condense it back. We make it into liquid and take it again, and again we heat it. We allow it to react. Are you okay with this ethanol reaction?
yeah,
Oxidation.
yeah,
Okay, that's it. Now we looked at the reactions what alcohol undergo. Again, only combustion and oxidation. Oxidation by microbes and oxidation by the reagent, potassium dichromate. Now we will see how we can produce ethanol. Okay, so put the topic production of ethanol. So ethanol can be produced in two steps: ethanol by fermentation and ethanol by the hydration of alkenes, right? Whenever we have an alkene and then we add water to that, we are going to get alcohols, right? So by hydration of ethene. Okay. Put the topic production of alkenes. The first way. We are familiar with the second type of reaction, no? Reacting ethene with steam or with water.
yeah,
Now see, alkene reacts with water to form alcohol. They have said water here, but see the condition is steam, okay? Go with steam, addition of water, but make sure when you're writing it with the physical state under the alcohol question, just go with steam, okay? Yes. Do you take this down?
I need to take that down.
Just only this production of alkenes and the two types or the two processes.
Okay.
Okay, now we'll just go
Two.
with the familiar one first. Put the subtopic hydration of ethene. So again, it's the same thing, okay? There will be an alkene, but it's eth, so two carbons with steam.
Miss,
Heat
is it
measure.
ethene?
Okay, ethene.
Ethene with steam?
That's how we produce. Okay, ethene. Pronounce ethene. Okay. So ethene and then water. That's steam. We have CH3 alcohol produced, and these are the conditions, okay?
You have to take that down, Miss.
Yes, take it down.
The H2O gas is steam, right?
Yes, it's steam here. Okay, so write it as reacting with steam. What did you say? Ethane. How did you pronounce it?
Is it ethene?
No, dear. It goes as ethene, okay?
Ethene. Oh,
Ethane. I just checked the pronunciation. Both British American both goes as that.
Miss, didn't we write this down? The
Yes, we wrote it
temperature,
under,
pressure,
yeah,
catalyst.
but just take it. It's okay. So this is under the production of alcohol, okay? Production of alcohol, two methods. One is fermentation, one is hydration of ethene.
And what's the product? What's the
Product is
product's
an
name?
alcohol. So it's an alcohol with two carbons. So how does it go?
So, ethanol.
Yeah, ethanol. So what type of reaction is this? Uh, Addition.
Hydration.
Hydration. Okay, again it says addition reaction too because water is added. Okay. Hydration means addition of water, right? So again an addition reaction.
Yeah, I'm done.
Okay, now see the ethanol produced is condensed as a liquid and the unreacted ethene, that is the gas, whatever present, is recycled through the process. So once now see our product is in the gaseous state, right? We can't store it, we don't have it in a gaseous state. So we again condense this and have it, okay? Clear?
Yeah.
Uh, If you want, you can take it down. The ethanol produced is condensed. Okay, next put the subtopic fermentation of okay, write this and then I'll explain. Okay, what is fermentation?
Fermentation is when you add yeast or any microbes to use, get a product of alcohol.
Yes, when do we have alcohol? That is when in the absence of oxygen, okay? That's important, yeah. Because when it is in the presence of oxygen, it will produce some other products. So when it comes to ethanol by fermentation, this is the reaction that we have. We should convert, we have glucose forming ethanol and carbon dioxide, okay? So here we can have yeast in the presence of yeast or microbes, like you said, but again, anaerobic conditions. Now see, not in the presence of oxygen. So can you take down the temperature? Conditions 30 degrees Celsius, catalyst. Why are we adding yeast? Because enzymes, yeast has enzymes which can convert the glucose to ethanol, okay? Enzymes in yeast. And other conditions, it should be anaerobic. If it is aerobic, the products will be different. Anaerobic means absence of oxygen. And then we'll take this down. So this is fermentation. Know the definition. So under aerobic conditions, yeast will produce carbon dioxide and water, and not ethanol and water. So because we need ethanol and water, we allow this reaction to happen under anaerobic conditions in the absence of oxygen. And again, why do you think we allow it to proceed at 30 degrees Celsius and not higher? Again, it's about the enzymes. What will happen when we increase the temperature? Enzymes?
Will they denature?
Yeah, they denature, okay, because enzymes are proteins. So the optimum temperature for this reaction is 30 to 40 degrees Celsius. Again, at lower temperature than that, they are not going to proceed because lower temperatures, enzyme action will be very low. Take it down and let me know.
Is it 30 or 300?
30 degrees Celsius. Okay, are you done?
Almost.
So denaturing, is it a reversible process or irreversible?
Irreversible.
What happens? The active site of the enzyme gets damaged. Okay, so
The active site, yeah, gets damaged, so it cannot work properly.
okay.
Wouldn't it be that the substrate wouldn't fit anymore in the
Yes, the
active site?
substrate won't fit anymore in the active site.
So in order to make alcohol, you need to have anaerobic conditions.
Yes, anaerobic
If you have
condition.
if you have aerobic, it would wouldn't work, or
Yes, if we have aerobic, what will happen? In the presence of
it
oxygen,
wouldn't form
it will form carbon dioxide and yeast, carbon dioxide and water. We won't have ethanol.
because the yeast would respire, right?
Yes. Here again it's respiration, but this is anaerobic respiration. This is aerobic respiration.
Is yeast a fungus?
Yes. Example of a organism in kingdom fungi. It's a unicellular organism, ne? Fungi, mushroom also comes under fungi. Okay, what are the kingdoms? Kingdom plants, animals, fungi, and we have bacteria. No? All these are eukaryotic or prokaryotic organisms.
Eukaryotic.
Plants, animals, and fungi are eukaryotic. Bacteria is a prokaryotic organism. That means they do not have an organized nucleus. Right? Bio. And then here, all these organisms, they have a organized nucleus. Their genetic material is enclosed inside a nucleus. That is the difference between eukaryotic and prokaryotic, right? The genetic material, if it is present inside the nucleus, then eukaryotic organisms. If it is not present inside the nucleus, if it's just freely present in the cytoplasm, the DNA, then it's a prokaryotic organism, okay? And fungi, plants, all the plants are multicellular organisms. Animals, multicellular, okay? Almost, yes, all. And then fungi, we have both unicellular and multicellular organisms. So one example of unicellular fungi is yeast. Multicellular, we can go to mushrooms and all that. Yeast cell, what is the cell wall made up of when it comes to yeast? It has a cell wall.
Cell wall.
Okay, what is the cell wall made up of? The plant cell wall was made up of cellulose. Fungi cell wall?
This one's made out of chitin.
Chitin, okay, yeah, this is chitin here. And then it has all the other organelles just like in a typical animal cell.
Okay, I'm done with.
Okay. So write these points. (40°C).
Miss, are you taking bio for, are you teaching AS biology? Because
Yeah,
I'm taking biology.
yes, I do bio and chemistry both.
So could you teach me bio when I get to AS?
When you get for your AS,
Yeah, when I start AS, is it
okay,
possible to teach it for bio?
yeah, would be possible, okay? Will do.
Yeah. Miss, for AS, when will you start tutoring? Or which next batch?
No, I
When's
don't
the
have
next
group
batch?
classes. I have individual classes. So whenever you want to start, we can start it, okay?
Yeah, sure. Thank you, Miss. Mhm. Okay, Miss, I'm done.
Okay, so that's it about the conditions and why we choose all those conditions there. Okay, and then whenever they ask you a question asking how we can purify alcohol or separate alcohol, it goes with fractional distillation based on their boiling points. That's how we separate alcohol from a mixture, right? Based on their boiling point. Okay, just know that. Then comparing the two methods of producing ethanol, so we have fermentation and hydration of ethane. Okay, now we will see the differences and the advantage. Which one do you think is more efficient to produce ethanol in industrial level?
Hydration.
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 Okay, hydration.
It's
Okay,
quick.
it's quick, no? And okay, so the rate of reaction, it's quick, and then here slow because it takes several days for each batch. The quality of the product,
And
it
it's hydration is more pure.
it produces more pure ethanol. Okay, and then here it's impure ethanol, so we need further processing. So that can also cost more. Whenever it comes to an industrial level, we should always think about the cost first, no?
This fermentation is used for like drinking alcohol, right? While hydration is used for sanitizers or something.
Yes, the proper alcohol there. Okay. Yes, drinking
Yeah.
ones we go with fermentation. Reaction conditions, gentle temperature and atmospheric pressure, but here high temperature and pressure, high input of energy. Okay, the type of process, it's a batch process. Everything is mixed together and then left for several days. The batch is removed and then new one is set up. So inefficient. Okay, once we supply the glucose, again we remove it batch wise. Here, continuous flow process. Reactants is constantly passed over the catalyst, so more efficient. It's not a batch process here, okay? And then use of resources, it's a renewable resource here, but here non-renewable resources is used because we use ethene here. Ethene is a non-renewable resource. One, what is renewable and non-renewable? Renewable, when we have glucose, we take it again, we can get new glucose, right? Or means like new sources of sugar, like sugar. Okay, it says sugar beet, sugar cane, corn, or any other starchy material. They are renewable. One time, if we just take all the sugarcane
Is
harvest,
how do
again
you
we can just have
harvest
it.
the ethene?
Ethene
Yeah,
is not
ethene.
harvested. It is like already present in the nature. They are non-renewable resources. Once we use it and once everything is done, that's it. We will not have any of that anymore. We have to find an alternative.
Ah,
So
okay.
see, once all the
But
oil
it's
has been
abundant now? Is it abundant?
yes, yes, it is abundant. Okay,
Yeah.
there won't be any more, so we will have to find some alternative. So this is a non-renewable resource. Are you okay with renewable and non-renewable? So ethene, not only ethene, the crude oil, all the crude oil,
Yeah, for
whatever
fossil
comes
fuels,
there.
crude oil, natural gases, and
Yes, all
ethene.
the fossil fuels in all. Okay, so all that are non-renewable resources. Once that's done, that's it. If all the diesel or petrol is over, we have to find an alternative.
Miss, can we use propane to get propanol using
Yes,
hydration?
hydration. Yeah, we can get propane if we react an alkene with water, it is going to be an alcohol. We will get propanol, okay? But industrial level production of alcohol, we just go with ethene,
Okay.
okay? But in your question, you can just get anything. Now, this is the industrial production. If it's always with an alkene hydration reaction, we get the alcohol of that particular thing. Okay, do you want to take this down just short, the comparison? You can write renewable resource, here non-renewable resource, batch process. This is continuous flow process, slow and quick, more pure ethanol,
Do
and then
I draw a table like that?
yeah, and then take all the points in short and send me a pic.
Okay, I'm done. I'll send you the table.
Yeah, okay, send it. So know the differences. Renewable, slow and quicker, produces impure, gentle steps, high pressure. Okay. Okay, now we'll just look at these questions. Don't write it. We'll just see. So draw a dot and cross diagram to show the bonding in ethanol. Ethanol, two carbons, right? And then with an OH. So H, 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 and H. Can you draw a dot and cross diagram first? Okay, you can do that. We'll just discuss the questions and go to the answers. Ethanol can be produced by the catalytic hydration of ethene. Describe two conditions. So what are the conditions here? Are you here?
Sorry, Miss, I was muted. It's 300 degrees Celsius temperature,
Okay.
and then 60 to 70 atmospheric pressure.
And catalyst is phosphoric acid, right? You
Yeah.
should know all that. In some countries, ethanol is manufactured by a different method called fermentation. State the raw materials used.
Raw material is
Yes.
those renewable sources, right?
No, we can't just say renewable resources. Even anything can be a renewable
So like
resource.
sugar beet.
Sugar beet, okay. Yeah. Or glucose, sugarcane, glucose, yes, like be specific, okay? Don't just write renewable
Yeah.
resources. And then explain why the following conditions are important for making ethanol by fermentation of glucose. Yeast is added into the reaction mixture. What's the reason?
Mm. Oh, yeast is added into the mixture, so it can ferment the mixture by
No,
uh, what's it called? The digesting the glucose.
what's the main point? Why we add yeast? It contains the enzymes which can convert glucose to ethanol and CO2, okay? So to supply the
Yeah.
enzymes is why we give yeast. Yeast has the enzymes. If you want, take it down. I gave you that point, but okay. Okay, temperature between 30 to 40 degrees Celsius is used.
So it's what's it called? Doesn't go into anaerobic.
No, temperature. Anaerobic is about oxygen, no?
Oh, temperature. So the enzymes don't denature.
Yes. Fermentation needs to be carried out in the absence of air.
So it doesn't go into anaerobic respiration.
Doesn't go into aerobic respiration, no?
Aerobic.
Yeah, and
Yeah.
you should also say that because in the presence of air, yeast will produce carbon dioxide and water, okay? So we don't need those products, right? We want ethanol and ethanol, yeah, okay? Clear?
Yeah.
To mention those points. Explain why some countries manufacture ethanol in this way. Ethanol in, they're asking the
It's
fermentation
cheaper.
way. Yeah. So you should write the advantages of that, whatever. Ethanol is used as a biofuel in Brazil. Write a balanced chemical equation for the complete combustion of ethanol. Can do it, no? Just plus oxygen and then giving carbon dioxide and water. You should balance it with the state symbols. Okay?
Yeah.
Physical state. Glucose can be converted to ethanoic acid in the following sequence. Okay. Can you do this question 3? Write down the answers and send me.
Miss, I can't see the questions.
Okay, which one are you doing now?
The first one, A. As for glucose turning into ethanol, C6H12O6 gets turned into CH3, CH2OH, right?
So you can write the chemical formula of ethanol. It means 2 carbons, no? And then write an OH, fill the others. Yeah, CH3, CH2OH, okay? Correct.
But then when I'm balancing it doesn't make sense.
Write a balanced chemical equation for reaction 1. No, you can balance it. So we have 3 carbons on this, right? So, wait. Glucose converting to ethanol plus carbon dioxide, and now balance it. That is how the fermentation equation reaction goes, right?
Oh.
So now balance it. C2H5OH plus CO2.
Yeah, it's 2 in front of the C2, yeah, and then 2 in front of CO2.
Okay.
Miss, I put CO2 in brackets. Is that okay?
No,
Without
no.
the front
Writing a
symbol.
reaction, write it as the whole thing. No brackets there.
What do you mean?
No, don't put brackets. Just write it as a whole reaction like this.
But then how would I like show that each of the what's it called? All of them are multiplied by 2?
You said you're saying this too.
Yeah, in front of that 2, I need to put brackets so I
No,
can
no,
multiply
no.
everything inside
Why are you
by 2.
multiplying it by 2? This is how we normally balance a reaction, no? We just put the number in front.
Oh, okay.
Okay, so if it's like this, if it's sodium and sulfate, then I have to cross it to write the formula. Then now, okay, let's take it as calcium and nitrate. Okay, calcium is 2, nitrate is 1. Now this 2 belongs to this whole thing now. Then I put calcium NO3 balance brackets 2. That is when we put brackets in the compounds. In reactions, we don't put brackets. We just put the number in front, okay? Understood?
Yeah.
Uh,
Miss, what does reagents mean?
Reagents means like any chemicals, whatever we add to those. Okay?
What's a reagent?
So this is a substance what we add in a reaction for reactants to react. Like another name for reactants. Okay, you can just take it like that
Oh,
also.
okay. So it would be ethanol and
No,
potassium dichromate.
Give suitable reagents for reaction 2 with ethanol. What and what do we react? That is what they're asking. Whatever is not mentioned here.
Potassium dichromate
And
and hydrogen.
no, dilute sulfuric acid, right?
Uh,
Yeah, hydrogen ions, we add it by that. So you should write it as dilute sulfuric acid.
can I give it in words or do I have to write the chemical?
No, write it in words. It's okay. So when you write in potassium dichromate, you should write it with the valency. Potassium dichromate in bracket 6.
It goes from orange to green, right?
Yes, it changes from orange to green. Okay, are you done? Send me answers.
Yes, I don't understand B part 3.
Okay, write a balanced chemical equation for the process using oxygen to represent the oxidizing agent. So for this
So instead of
reaction,
ethanol,
no. For this reaction, they're asking you the balanced chemical equation.
I use oxygen.
No. using oxygen as the oxidizing agent. Who is the oxidizing agent?
Ethanol.
No. Go to the note.
Oxidizing agent. Potassium dichromate. Okay.
Yeah, potassium dichromate. So you draw ethanol plus oxygen, ethanoic acid plus some products, whatever, water, then balance it. The same reaction that was in the textbook, okay? This reaction. Clear?
Yeah. Okay, I'm done, miss.
Okay, send the answers.
Wait, I forgot to do C. Ethanol can be converted into ethanol. Ethane. Ethane. Water, right?
Yes, water.
So, miss, isn't it a reversible reaction?
You're asking if that's a reversible reaction.
Because look in the note, production of alkenes, ethene plus steam gets turned into ethanol. Then you can turn ethanol back into ethane.
No, it's not reversible because we should provide those conditions, okay? The conditions are different for both, no?
Oh, yeah.
So that can't be reversible.
Do I need to put state symbols?
For this, no. And you don't put a bracket in front when balancing equation. Okay, you just put only the number. Dilute sulfuric acid. B1. Ethanol, dilute sulfuric acid, and what else? Give suitable reagents. Potassium dichromate. Okay. You have written that. Okay, correct. Goes from orange to green. Okay, that's correct. Can you put a double bracket here? So, that's correct. Understood after this?
Yeah.
Okay, that's it about alcohols. So next class we'll look at carboxylic acids and esters. Yeah. Okay, I think we can be done with organic in 2-3 classes. Okay, then shall we finish it for today? Do you have any questions?
Yeah, sure. Yes. No.
Okay, then bye.
Okay, bye, miss.